Hello, I am John Bell from Circuit Design in Japan. In this video, I will talk about radio modules we sell at Circuit Design. I'll explain the Circuit Design radio modules in the following categories in order as shown: telecommand, audio, remote monitoring and remote control. So now I want to talk about telecommand operation. Telecommand allows transmission of on-off signals as shown. This would allow applications such as activating machinery and remote switching, for example to turn on an irrigation system, or switch on a warning beacon when a sensor is triggered. So one of the important requirements is to minimize the possibility of receiving an incorrect on-off signal. The Circuit Design NK2.4Y module incorporates Hamming distance of 6 to allow error detection. What this means is that if an error is determined to have occurred during transmission, the module will certainly not output the incorrect signal. In addition, the NK2.4Y features frequency hopping spread spectrum to minimize interference from other nearby radio systems in the 2.4 GHz band. For handheld operation, small size and the ability to operate on battery power is important. So, small low-profile modules such as NK2.4Y is small and includes antenna already. This module can operate on low voltage such as batteries. The NK2.4Y and CT modules have direct connection for input and output signals. You can see that one module can process up to several switching signals. 6 signals for the CT and 8 for the NK2.4Y. Therefore, the engineer does not need to spend any time to develop a complex interface to use the modules. There may be several equipment that need to operate in the vicinity, so the ability to have one transmitter-receiver pair for each equipment is useful. The NK2.4Y allows one-to-one link with a second NK2.4Y. For CT modules, up to 100 transmitters can be registered. To ensure that the user stays within the communication area, an easy-to-see confirmation of communication is helpful. The NK2.4Y has an output that confirms the communication link. The NK2.4Y also uses frequency hopping spread spectrum, so the engineer does not need to worry about selecting the correct channel. The CET modules are available in 434 and 426 MHz versions. 4 channels can be selected using the dip switches. The NK2.4Y uses worldwide 2.4 GHz band. Introducing Circuit Design wireless audio modules. These allow wireless transmission of analog audio signals of up to 13 kHz in the European Harmonized Audio 863 MHz band. An important requirement is maximizing the quality of the audio within the limits imposed by the frequency band. To optimize audio quality, Circuit Design implemented a process called companding. This produces good dynamic range even in the bandwidth limits. At the receiver, the module can perform decompanding to restore the dynamic range. For stable communication, these modules use analog FM modulation, which is immune to fading and dropouts. This means it does not suffer dropouts, as would likely happen in digital communication. When transmitting the audio digitally, a disadvantage is the DSP process can introduce delay between transmitted and received audio. By using analog FM modulation, the latency is near zero, so there is negligible delay between audio transmission and reception. These modules have already been designed specifically for this application and has all the necessary circuitry. So all that is required is connection to a device with an analog output, such as line out. Channel selection, RF power selection, and audio muting are set by applying H and low signals to the module terminals. The compact size of the transmitter makes it easy to embed into the user's product. Regarding frequencies, Circuit Design sell audio modules for both the 863 MHz and 808 MHz band, allowing use in Europe and Japan. Circuit Design also sell modules for serial data, both single and bidirectional communication. Such data can include environmental monitoring, for example temperature, humidity, or transmission of utility measurements, for example water level readings. To avoid bit corruptions, especially over longer ranges and electrically noisy environments, circuit design modules incorporate certain measures. For example, incorporating Reed-Solomon code in the MU4 provides immunity to burst errors, improving communication reliability. For remote monitoring, long range is achieved by using modulation techniques that increases receiver sensitivity for much lower data rates, e.g. 15 bits per second, such as in circuit design smart modem SLR434M. This can potentially increase the range from 600 meters up to several kilometers. Also, circuit design MU4 modem allows you to use the same module as a relay without extra components. User can include up to 10 relay units. This potentially increases the range from 600 meters to 6 kilometers. To ease development efforts, circuit design MU4 and SLR434M implements a command system to handle the transmission of byte data. The command protocol allows the user to do other extra functions such as remote RSSI inquiry, route messages around networks, configure user IDs, for example in a sensor network. Note that users that would like to implement their own protocol can do so on the MU4 and on other modules. This last chapter talks about remote control of machines and equipment. For example, a user might want to control a boom on a machine, or remote control a winch in the forest, or in recreational applications, for example stage lighting control. For remote control on a construction site, there may be other equipment nearby. This can cause the signal to reflect, be blocked, or change polarization. In addition, the user is in constant motion with the remote while controlling the machine. All of these can contribute to communication dropouts. Implementing receiver diversity helps here. The user can maintain stable communication. The ST503 module incorporates direct sequence spread spectrum provided by a custom ASIC. By spreading the signal with a chip code, this allows reliable communication in the 2.4 GHz band with minimal interference from other 2.4 GHz devices. When operating in the field, high blocking performance of our modules allows reliable communication in the presence of other on-site equipment transmitting in adjacent frequency bands. Narrowband and channel selectivity allows channelized operation, meaning multiple systems in one area. Our receiver modules fall into receiver category 1 where applicable. By this, the receiver must not only receive the desired signal adequately, but also not have its receiving performance degraded by nearby undesired signals. We call this the near-far problem. For example, a transmitter and receiver can achieve very long range when no other signals are present. However, when we introduce undesired signals, such as those in adjacent channels or near to the frequency of operation, the range can be reduced. This would be undesirable if several remote controls are in use at the same time where the signals would be in close proximity to one another. By using high-quality discrete components, circuit design modules can achieve high blocking and adjacent channel selectivity that minimizes this interference. When operating on the field, the weather and seasons mean users need to be able to operate their equipment in extreme temperatures. As temperatures fluctuate, so can the oscillator that governs the operating frequency. Thanks to the TCXO in circuit design modules, this makes continuous adjustments that stabilizes the operation frequency, which allows communication in a wide temperature range. Remote control done on site means portability is important. Low current and voltage consumption of the modules allows portable operation using batteries. When making the same module for other frequency bands for use in other countries, circuit design makes every effort to maintain identical housing size and pin layouts. This allows users to export their product to other countries without any major redesign. One more approach circuit design has taken is to combine several frequency bands in one model. The STT601 is a multi-band model allowing you to select the band of use in the 400 MHz range, specifically 429, 434, 447 and 458 MHz. We hope that this presentation has given you some idea of the capabilities of radio modules by circuit design. For more information you can visit our website here.